Yes. Oh, I like that a lot. Okay. Thank you so much for watching the video. I hope you enjoyed the puzzle. Until next time, bye. I always forget I'm like recording a YouTube video too. Hello and welcome back to another video. Today's puzzle is a Skunkworks collaboration between Riffclown and Heliopolix. Riffclown I have in the chat with me, so that's always a pleasure to get to do someone's puzzle with them here, especially in case you get stuck. But hopefully we won't get stuck, at least not too bad today. We've got the rest of Twitch chat to help me with this one. Let's read the rules. This puzzle is called Filaments. And we've got normal Sudoku rules apply, so we're going to place the digits 1 through 9 in every row, in every column, and in every 3x3 box. We've also got some givens here, which we don't see too often these days. Region sum lines. So digits on a line sum to the same total for each box the line enters. Different lines may have different totals. I think these lines are multiple kinds of lines, and that's what's going on here. Very pretty construction. So the blue dots is the normal region sum color. God, I wonder how long it took you to make this. I feel like that's just placing a bunch of different dots. That's really cool. But yeah, that's beautiful. So what that means is that the sum of these three digits, whatever they're going to end up being at the end of the puzzle, will have the same as the sum of those two digits, and it'll be the same as the sum of these three digits, because that's how the region sum lines work. But I think these lines do more than one thing. They're also entropic lines. So any set of three sequential cells along an entropic line must contain a low digit. That's a 1, 2, or 3. So this could be, let's say that's 1, 2, or 3. And then a middle digit, so 4, 5, or 6, and then this would be a high digit, so 7, 8, or 9. Now it could be in a different order, so this could be the 1, 2, 3, and this could be the 4, 5, or 6. We don't know, but we do know, let's say this was the order, that because this is also a set of 3 cells along this line, this would have to be the same entropy as this digit that sort of fell off the back end of that string, because this is one of each kind, and then this is one of each kind, so this has to be the same as that. So this would also be 4, 5, 6, and then we would get 1, 2, 3, and then we would get sort of 7, 8, 9, in that sort of repeating fashion around the lines. All lines in the puzzle conform to both rule sets, and that's it. That's all the rules. So nice, pretty straightforward rule set. We're gonna have to think pretty carefully about how this works. But yeah, so there's a link to the puzzle in the video description. Please have a go yourself, but I'm going to solve this now with the help of my friends in Twitch chat. And I think where I want to start, I mean, this is silly, but how could this be this sort of low entropy? Right now, normally with the lines, you think like you start with a big line, and especially with like region sums, you're looking for big disparities. But actually, I think because of the sort of modularity, the first place I think to look is actually here, because if this was low or if that was medium, then there has to be a high digit here, and that's going to break the region sum totals. So that's going to be high, and that's going to be high. Do we have any other lines like that? I don't think we do. If this was low, that has to be 1. And if that's 1, then that would have to be 6, 7. Alternatively, the low digit could be, it can't be a 2, so it could be a 3. And then the middly digit, it could be any of those, huh? Okay, so if that's low, then it's very forced, because that it sees 2 and 3 in the row, so it could only be 1. But of course, that doesn't have to be low. These lines would mess with me greatly. I'm very excited to explore the interactions here. Right. I wonder. Ooh, I was gonna say, I wonder if we should color these for entropy. I think maybe I will. So we'll do like the coldest digits. We'll do some middly digits in maybe like yellow, and then our high digits. It is quite cool that we have one of every given digit here. 1, 2, 3, 4, 5, 6, and then 7, 8, and 9. I don't know if that's strictly necessary, but I quite like that. Not the interactions, the fact that the lines are made of circles. Oh, just the disposition of the lines. I'm sorry. It's good to note, though. I think as constructors we have might just be screen brightness too. Okay. It's not giving me a problem. I don't know if there is an alternate version for this, but hopefully it's not too bad for you right now watching. So which of these, are any of these restricted at all? I mean, I think it's all just 3 and 2, right? But there's going to have to be a high one. Okay, so the point is there's a high, middle, and a low. So what's the lowest that this could be would be 7, 4, and 1. So that's 12. And then if we didn't have a high on here, the highest we could get to is 6 and 3 is 9. So that doesn't work. So I guess the point I'm trying to say is because we have one of every entropy in these strings of 3 here, and probably the same is going to be true there. But I'm just looking at this line. Yeah, so let us know, or let Riffclown know. I know you've done fantastic work in making your puzzles accessible. Actually, I should pause here because I don't often get a chance to talk to you directly, Riffclown. But I really love that this community is very sort of proactive and making accessible puzzles for different people in the community, using line thickness to sort of avoid sort of color problems. And then when you have puzzles that have sort of aesthetic things, I know a lot of people will put in not just colorblind friendly, but like less. So if you do like beautiful like circle type overlap things, doing it with sort of clean square lines to make it sort of easier to interpret. So just that kind of stuff I think is really good. So let me see here. Anyway, so thank you for that and for your offer to do an alternate version if people find this difficult. That's good to know. Yeah, I'm with you there 100%, Riffclown. We do this for people to make these fun for people to do. So I appreciate it, but I know that it's effort. So I feel like it's worth commending the effort that both you and a lot of other people in the community do, trying to make these accessible, especially when we use colors for so many things. So heck yeah, I'm all about that. Let me see what Skojo's saying. Important to note that the only time low, medium, high plus low, high is 1, 4, 7, and 3, 9. So, okay. So it's going to be forced. So, okay, let's get back to the maths here. We've definitely got a high digit here, because the lowest this can be without, or the lowest this can be, because it's one of all of the entropies, is 1, 4, 7, which is 12. Without a high digit, the highest we could get to is 9. If we had a high and a low, it's correct that we could have 9, 3. So the question is, can this be high, low? And the only way that works is if it's 9 and 3, and then this is 1, 4, and 7, right? I think that's the point Skojo was making here. Yeah. So it is possible, unfortunately. But then this would also have to be 1, 4, 7. Does that break for some reason? It feels like it must. I'm not sure how, though. There'd be a 1. I mean, Again, I don't know that this is, I don't know if starting to rule out one possible, maybe that is important now. Because I mean, if we can do that, then we can say for sure that both of these are low, which would be important actually. So if we can rule out, there will be an alternate version out before the weekend. Thanks, Riffclown. That's awesome to know. Very cool. And thank you for bringing that to attention, Isaiah. I love it. Right. So I'll try to remember to post the alternate version in the video description as well. So if you happen to stumble across this beautiful puzzle through my video, then I will do my best to remember to get both this link that looks like this and an alternate one that is potentially less troubling for people who have a hard time with those sort of dots repeating. Right. So we know that we've got one middle and one high, or one middle and one low here, and one high on here. Probably a high and a middle, but we don't know for sure. It could be 9-3. Oh no, if it is 9-3, then that, because of this 9, it would have to go there. So that was correct. It would have to be there because of that. And then now there would be a 1 here. 4 up here, because this would be all 1, 4, 7. It would be the same modularity. 1, 4, and 7. That would make this line very high, or significantly higher, because now the lowest this line could be would be 2, 5, and 8, which would be 15. So then this gets a little bit trickier, because the only way we could get to 15 is 9 and 6. That's really going to be forcing. Yeah, so the point is, if this is 1, 4, 7, we've used all of the low modular digits within the 3 different entropic sets. So now the lowest we could make this 3-cell line is the medium modular. I say medium modular, but the 3 mod or 2 mod 3 set of entropic digits. Meaning, yeah, what? Anyway, this is the lowest I could make this run now. And that's 15. So now this would have to be 9-6 for this to work, because the only way that would we could get to 15 in 2 digits given 2 different entropies is the highest of high and then the highest of middle to get us to 15 there. Now where would 3 go in box 2? Yeah, that's true. That feels like, I mean, so it breaks. But I'm wondering if, yeah, I mean, that breaks. I'm okay with that. So that's not true. So that I'm a little wary that is bordering on something I couldn't have seen without it. But I'm cognizant of the fact that it would be the same here, I think, too, if this was that. So almost as if it's kind of intentional geometry in that regard. Oh, that's Riffclown. You're saying that. I thought that was somebody else writing that. Well, if you're saying that, then I feel a lot more comfortable seeing the spotting to accepting that. I was worried that that felt like I was just going down the rabbit hole. But I mean, I could actually see all of this, right? 1, 4, 7, 2, 5, 8 being forced, 6, 9 being forced, and I can also see that these 3s and 9s are kind of placed carefully in such a way as to affect these. So the same is true down here. If this was a low and a high, that would have to be the 3, and that would have to be the 9, right? And then we get 1, 4, 7, 2, 5, 8, and that would be 9, which is maybe it is possible down here. Actually, it's different on this in this line, isn't it? Is there going to be another way that this breaks? 2, 5, and 8. I wonder. Okay, well, this one breaks. I just feel like there's something more I could be said. So this is 2, 5, 8. This is 3, 1, 4, 7. So this has to be 3, 6, 9 is the point. This would have to be 3, 6, 9. So that would be 9. That would be 3. And that would be 6, which means that's 9. Now we have to put 9 on this line. Can't go there. Yeah, it's going to be weird. Okay, so let's go back because all of this has just been sort of started from the, oops, this is actually correct, pencil mark. We started from the proposition of can this be a low and a high? And we did prove that it breaks in this box, but because we end up with a 1, 4, 7 and a 2, 5, 8, and then we have to have 3, 6, and 9. So that's a 9. This has to be 3, 6, and then this has to be the 3 because this is a 3, 9, and it sees a 9. So the other way to see that is this is all the same modularity. All of these become the same sort of modularity, and that's 4 different digits from the same modularity in the same row. Okay, so I'm comfortable with this breaking. I don't know that I can make a universal statement about that because I didn't see how that applied in every context without the given digits. But we do know that it breaks here. So these are going to be a medium and a high, which means that both of these are going to be low digits. Unfortunately, we don't know the rest of how that works. Hey, Screaming Ice Cube, welcome. Right. So let's think about it on these lines then, because I think it's going to be the same thing. In terms of the sort of mathematics of it, at least. And we'll have to see how the geometry plays out. But actually, where would it be the most restricted? Yeah, okay. So if either of, yeah, it's interesting. So if this is a low and a high, then this is 1, 4, 7, and then this has to be 2, 5, 8 at minimum. And then we get 6, 9 again. So that becomes 6 and that becomes 9. Not sure that's quite broken, but so let's look at this. Okay, so if this is 9 and 3, this would have to be 1, 4, 7. Oops. And then this at most could be 2, 5, 8, and that's 6, 9. Now I'm not sure that that breaks in this. I'm not immediately seeing how that breaks. I do see that this becomes a 6, 9 pair, right? So that has to be 9 and that has to be 6 because we're getting the same situation where this becomes the 2, 5, 8 and then this has to be 3, 9. So that's 9 and that's 3. Yeah, okay, so the point is, I think the way to think about this is that if any of these 2-cell sequences are a high and a low as opposed to a high and a medium, then it creates a world where we need to have a 1, 4, 7 and a 2, 5, 8 in the box adjacent to it, where there's 2 lines. So the only place that could be possible is in a box where the 3 non-lined cells can be 3, 6, 9. So, for example, this can't be, because if this was a low and a high, that would have to be 9, that would have to be 3. This would have to be 1, 4, 7. That's 2, 5, 8. And now we need the 8, right? But the 8's missing. That's really cool. So there is a universal thing that we can say about it. Let me get rid of this. But what that means is that this one can't be. because we have that 8. So this is a high and a low, and these are going to be, or a high and a medium, excuse me. And these two cells are going to be low. I have a color for low, don't I? So let's do that. Right, that's beautiful. I mean, that's a fantastic start. Let's see if we can do it in any more places. Unfortunately, I'm not sure because these ones we don't know. We don't know. So I think it's still possible that, oh, well, hello, that's a 1. Right, so this isn't low. So that's a medium digit. Do the obvious Sudoku, right? Now that's going to be a low digit, and that's not 1 or 2, so that's 3. Now this could, I think, actually be any of 4, 5, or 6. Oops. Let's get on the right cell. Okay. Now this can't be, whoa, I already knew that couldn't be low. This, we do need a low here. Maybe I meant to think like, where's 7 go in this box? Or where does 8 go in this row? No, I don't think that's it. I do know that we need a low in one of these, so that's not it. So that's not low, but we already didn't really expect it to be low, did we? Just because then that would have to be low, right? So that's not low. I wish I had a not low color. Let's see. Okay. Yeah. So if this was 1, 4, 7, and this was 2, 5, 8, and that was 2, 5, 8, this would have to be 6, 9. Then what's this? Oh, I don't think it works because it sends 6, 9 into both of these. Is that true? Yeah, if this is 9, 3, okay, this is cool. This is cool too. And I think a much more general statement. If this is, oh, I think I already proved that this one couldn't be just because of the 8, and this one because of that. But the point that I wanted to make is that if this is, yeah, if this was a, I don't think I needed it at all, huh? Because I already proved both of them individually. I think there's a way to prove it more conclusively, independent of the given digits, which is that if this was 9, 3, for example, this is 1, 4, 7, that's 2, 5, 8. But then this is also 1, 4, 7, and that's also 2, 5, 8. And then both of these have to be 6, 9. And so it breaks because they both sort of chain around back into box 5, which I think is the sort of universal way. Like, independent of any given digits, I don't think either of these could be a 9 and a 3 because it would put too many 9s and 6s in that box, which is very, very cool. Although unnecessary at this point, I think, to prove. But what I'm wondering, can this be 1, 4, and 7? Because if that's 2, 5, and 8, we're at 15. This has to be 6, 9. And then this has to be 2, 5, and 8, which means this has to be 1, 4, and 7. Wait, no, it doesn't. If that's 2, 5, 8, that doesn't force this to be 1, 4, 7. That's not true at all. It doesn't quite work the other way because it's less forced. Yeah. All right, let me walk through that again. So the question was, no, I don't think that's going to be as forced at all. Okay, so what's the next step then? We've got a low or a medium and a high here, and a medium and a high here. So if this is a medium. If these are both medium highs, in other words, neither of these are the 9-3 combo, then that's a medium and a high, or a high. That's medium. All of these become medium high digits, and that means that this, well, since that's low, this becomes medium and high also. That becomes medium and high also. And then these become lows. That actually seems quite likely to me, with this, and this becoming low digits like that. That feels actually quite likely, doesn't it? Okay. What do we do then? I want to break the possibility of this being a 9-3, or force one of them to be a 9-3. Actually, would be more useful, because then we get 1-4-7, which becomes very useful. Yeah. So okay, if that's 9-3, then this is 1-4-7. This has to be 2-5-8, doesn't it? 15, and then that's 6-9. That's 1-4-7. That's 2-5-8. Oh, I'm gonna just let me just look at this, because I'm having a hard time doing it all in my head. If that's 3-9, this becomes 1-4-7, and then this becomes 2-5-8 for sure. So 2, 5, and 8, and then this has to be the 9-6, because that's the only way that works, right? And then this has to be 1-4-7. I mean, I'm ignoring pencil mark sort of. I'm just trying to, because I want to disprove it this way too. So I'm trying to ignore the sort of givens when I do this. That's 1-4-7. Now this has to be 2-5-8. This was what I was trying to get at before, and for some reason I thought that it didn't quite have that same effect. But if this is 2-5-8. This is, did I do this? Yeah, then this has to be 9-6. This is, I feel like I was on the cusp of this earlier. The point is that the way that the chain works around, if you have a high and a low, then we go 1-5-7, 2-5-8, 6-9, 1-4-7, 2-5-8, 6-9. And we have to put 9 in both of these, because the 3-9 is required if you're using a low digit, and then that forces 1-4-7s to create 2-5. Yeah, okay. I can see it. I can see the whole sort of pattern working through, and that didn't rely on any sort of given digits. That's just the way that it cycles through. A low and a high forces the low modular, forces the medium modular, which now pushes us in the world where this line has to go 2-5-8, 6-9, or, oh no, I am I breaking this again? I think I'm breaking this in my brain. That's not true. Okay, let me. I gotta do this slower, because I think I'm going crazy. This would be 5-8. Now this, to make this 15, has to be 6-9, but this doesn't have to be 1-4-7. That's complete malarkey. This is how I did it in the first time through too. This doesn't become 2-5-8 again. This has all the options in the world. It just needs to sum to 15. I mean, I do know that this one would have to be 1, which would mean this has to be 14, which is a little bit restricted, but it's far from the end of the world restricted. Certainly it's not forcing this to be 2-5-8 and then making that 6-9. Okay, so I was not on the right path there. It feels like it wants to do that, but it doesn't do that. That's not true. It's only true if this is 1-4-7, then it forces that to be 2-5-9 also, which it certainly is not. So if there is a, okay, so let's backtrack. I was not correct there. Now we certainly can't have two, we certainly cannot have two high and low combo or high low combos. We could have potentially one high low combo, 9-3, and then we could have a medium high combo. But certainly there's two highs there. We did know that, of course. And that is interesting, actually, because there's a high here and a high here. And then there's a high here and a high here. So actually, one of these two cells is a high, making a sort of virtual high triple. And one of these two cells is a high, making a virtual high triple with those. So if that's high, that's high. And if that's high, that's high. So we're getting like, something like that. One of those two sets is true. Now, can we use the givens to rule one of those out? I don't know. And one of them is, now if it was, I think the same might be true for middles too, right? So if there is no 9-3 on here in the middle box, thank you. If there is no 9-3 in the middle box, we would have the same thing with middle. So we would have a virtual middle like that, and then a virtual middle like this. I mean, this is what I was looking at earlier, which forces all kinds of low digits, right, in these positions. But I'm not, where does that take me? What if there isn't? So if this is a low, then we've got a middly digit there and a middly digit there. And that's high, so that's a middly digit. Now that's high. Well, I can say that this is never high, and I think that that's always low. Because one of these two is high. There's no highs. And then there's, I don't think we can, yeah. So the point is, let's say this was the low. Let's say we were in a world where we can do 9 and 3, right? Then this is going to be the other high digit. We'll make it 8 or something. And then this is going to be a middly digit, 6. So we have a high, middle, middle. That's all our middles. And then high, high, high. So we would get low, and that breaks. Does it break because the only place we can get, how do we get enough lows in this row? It's not there, and it's not there. So, and it can't be, it can't be there and there, right? So let's say, I mean, I could say, oh, well, this could be low, but then I have the same problem in column 5, right? So it's just mirrored, it's just rotated, because these are the same in all of these. In those positions, I mean, the puzzle isn't exactly 90-degree rotationally symmetric, but these sort of segments that have middle and high on it. In fact, why don't I do this, right? I'm gonna use my colors. That's a middle and a high in all of these, right? And then one of these is going to be a high. But let's try to do it here. So we've got a low there, okay? Where's the other low coming from? Well, that's a low. So that's a low. And cool. So I think that's not a low. So that's a low. So those would be low in this world. But now here, where are we going to get our lows in this one? Because this can't be low again. And that can't be low. So so what's this? We've got all of our highs, we've got all of our middles in this combination. So that has to be low, but it breaks there. So it doesn't matter where you do it. So you can put a 3 in a column, or I could put the 3 there, and it's going to give you enough in that it'll be satisfied. We can find enough lows in its own column or in its own row. If I made this the 3, for example, or if I made that the 3, whatever it is. But then the 90-degree rotation of that central axis in the puzzle breaks, because we won't be able to get another 3 because it'll be too close, or another low digit, another low entropic digit, because it'll be too close on these lines. That's freaking cool, man. So unfortunately it's less restrictive, but that's really cool. So what are these? I think I can actually keep these colors there. That's not, oh no, I don't know these, I don't know those digits, but I do know that these are now all low digits. I like that a lot. That's freaking cool. That's a 2. Now, yeah, I already knew those weren't low. Okay, so that's kind of what I expected, but I feel like we did do a more solid proof of that. I wonder, Riffclown, if that's, I mean, it feels like you were applauding me when I sort of spotted this, but even seeing how it breaks, yeah, in the other column, it's kind of tricky. I love that though. Right. So the 2 middly digits on here are 5 and 6, because we already have a 4 given. So 6 is in one of 3 cells. I don't know if that's worth denoting here. Okay, so that means that none of this is forced. If there was a 9-3, there's a lot of interactive geometry in this arrangement. Yeah, this is very cool. Very beautiful. So that might have been your way of saying that wasn't the exact way that I wanted you to see it, but it works. There's probably different ways of probably several different ways of doing it. I quite liked that one, or at least that's the way that I saw it. So maybe we do a little bit of Sudoku. There's a 2 over here, and that means that none of these are sort of blue. I don't want to go about coloring all of them as just, this sort of hash mark, or this sort of dual colored thing. 1, 1. So we have a 1 down here. Okay. Now, I guess one thing to think about is that I didn't realize it before, but this is 2 of each entropy. So that's the high. So these aren't any highs. So that's going to be a low and a medium. And the same will be true of these 2. So that's a low and a medium. And obviously this is a low and a medium. But these 2 being a low and a medium, and that's a low and a medium. So we've got, another sort of virtual medium Z's thing going on there. So that can't be the medium, can it? I think that has to be low. Which is really weird to say, but let me go through this again. So in this box, I know that this is 1 of each entropy, this is 1 of each entropy, and that, oh no, that's a medium. What am I doing? Okay, hold on, that's all backwards, all kinds of backwards. Okay, that's a medium. So this is a low and a high. Okay, I got that wrong. Thanks, Helio. Good to see you. Cheers. Thanks for the puzzle. I'm really enjoying it so far. Let's see if we can do it some justice here. I don't know why I was thinking this had to be, like I just didn't see that was a medium entropy. I thought that was going to be really cool and give me a low digit there, but that's nonsense. So this is a high and a low over here, which doesn't help us in the same way. Okay, so maybe we need to do the maths then. I've been putting it off. Is it time to do maths? So there's no more mediums on here. There's a 5 and a 6 in there. That can't be 6. That doesn't mean it's 5, but 6 isn't one of these three. And I'm not immediately sure what I'm supposed to look at next. Also, I don't know why I switched to green from yellow. That's weird. I think I'll just stick with green though. I don't know why that happened though. So green's my middle digit. Sort of like land. We got water and then land and then like mountains. That's how I'm going to remember that. Low, medium, and high. All right. Is there anything that I'm missing in the puzzle? Box 5 and 7 and 8 should be interesting. 5, 7, and 8. Okay. So maybe it's time to turn to our sort of given arrangements. So 4, is it? 4 is in one of these. Now 4 was on here. That puts us in a really low spot. That would be max 14. That's not that bad, actually. This can't be 8 or 9. So if that's a high digit, it's 7. I mean, that's either 4, 5, 6, or 7. We can do that. Now, if that's 4, 5, or 6, if this is, maybe I have to think about, this is 5 and 6, and it can be 8 and 9, right? So the most I can get from these would be 14 a piece. I could average 14, 28 total. Do 9, 5, and then 6 and 8. But what does that do for me? I'm wondering, can this be 7? If that's 7, the most I can get here is 13. Now, what does that do? That means these has to be down to 13. And the most this could be would be 15 if I did the 9 and the 6 in the same box, which would put a lot of pressure over here. Yeah, okay. Because these two sums are the same. They're the same as whatever that is, right? So, I mean, if I tried to cheat it and go like 9, 6, and 1, 15, that just takes away from my ability to do the other one, right? So, because then that one's 15, but now the other one is 8, 5, which is 13. So that means that this would be maxed out at 13. So that actually makes it harder because one side of these would be lower, right? So ignoring the 1 and sort of the fact that I know that there's a 1 on this, it's kind of symmetrical in that sense if you don't include the digits. So the point is that if this is a 7, the most I can make this is 13. So the most I can make this is 13. And then on average, on one of these would both be 13. And then if I could do them both at 14, so then this would be 27, which seems like a lot, right? 1, 2, 3, 4, 15. It's a 6 cell, so you can do that with triangular numbers, but you can't just leave 7, 8, and 9 off. In fact, you would have to have. The point is, there is a 9 and a 7 in this. There is a 9 and a 7 in here because this has the other high in both of these. So we could do 9 and 7 is 16 plus the two lowest middle digits. That's 4 and 5. So 9 and 7 is 16 plus 4 is 20 plus 5 is 25. Plus 3 is 28. So the minimum that we can make this, that conglomeration of 6 digits, because we don't have the 8, even using 1 and 2, is, what did I say, 20? Oh shit, I already forgot. 28? Yeah, because 9 and 7 is 16, 4 is 20, 5 is 25, and then the 1 and the 2. So 28 is the lowest I can make this. So let's say we gave this, 6 and 8, so 14 on average. We'll see if I can do 15 even, because that would be the max, but then that makes this harder. So let's do 14. 14 and 13 is 27. That's not enough. Ooh, but it's only not enough by 1. So the question I'm going to ask is, could this be 6, 9? This all started from the proposition is, can this be 7? Because if that can't be 7, then we know the sort of entropy all around it. Welcome back, Riffclown. So the question that I'm asking, I started by asking, can this cell right here be a 7? If that cell is a 7, the most I can make this is a 6, so that's 13. And the most I can make this is a 6, 9, which is 15. And I think that's going to put a lot of pressure on this box if I max this out this way, because now this can only be 13, which makes this only 26. So I think this is going to break over here, but I don't know that it breaks quite yet in this, because actually it does. It just, I can't do 9, 6. I don't think, because I have to have a 9 in here and it can't go in there. So now 9's over here. So I know 9 cancels out with 9, and then 2 plus some digit has to equal 6, and that 4 would rule it out. So actually, I do know that this couldn't be 9, 6. So now this can't equal 15. It can only equal 14. And And I think that that breaks. So if this is 14 and this is 13, the most we can get to on this is 27. And we already did the math and added it up that this had to be a minimum of 28 because it could be 9, 8, 5, 4, or sorry, 9, 7, 16 plus 4 is 20 plus 5 is 25 plus 3 is 28. So the math doesn't work here because we can't put 15 there. Now, I think even if we could put 15 here and Sudoku didn't break it, putting 15 there would have broken it over here because we stole one from this. And instead of going 14 and 14, we made it 15 and 13. And I think that that was going to break this, even though we have one extra degree of freedom because we can use 8, 7 instead of 9, 7. We would have been down 2 degrees of freedom. But in any case, that doesn't work. So that's a very, very cool and complicated way, but legit to prove that this can't be 7. So we know that that's middle entropy now. Nice. And that gives us the entropy for this whole line. So this now is high. This becomes not high, and this becomes high, like that. And now this becomes high, and this becomes not high, like that. Right, so let's go ahead and give these some pencil marks. This one isn't 9, 5. Right, now we might, oh, this one is a 9. That's cool. So that's the 9. So 10. Okay. So now we know there's a 7 there. Oh, that's cool. That's fabulous. Because we did know that there was 9 and 7 on this line. So that isn't 7 up here, but most importantly, we get the sort of coloring of this. So that's green, that's green, that's high, low, middle, and then high. And all of these, so this is the middle, so that has to be the 5 now. These aren't 5. Oops. And remember before we oops, why didn't that work? We said that this can't be the 6 because that's too many middly digits. So that's got to be the 6. Let's get rid of just these corner marks completely. And that's fabulous because that gives us the entropy of this line over here. Wow. That's so cool. I wonder if I did that the sort of intended way there. There might have been other spots where it broke easier. Oh, it was really tight. It was really tight. And actually using the 4 to break it here was cleaner because I thought I was going to have to bounce it back over to here to prove how stealing a digit to make that 15 then broke in this box. Okay. So a little bit of a roundabout way. I don't deny that. What's nice about this kind of puzzle is even the sort of roundabout ways feel very beautiful. And there is a roundabout way if you're somebody like me who ends up needing it more often than not. So let's go ahead and see if we can put some center marks in these because we get things like that. It just has to be a particular digit, or we get, yep, that's a 6 now. So that can't be middly, so that is low, but not the way wait, whoa, what did I do? Did I do something wrong? I was thinking, where does that can't, I don't know what I was thinking. That is the 5. And then that's low. Okay, that was weird. I don't know how that happened. Let's, I don't know what sometimes my brain just doesn't do this very well. Okay, 7, 8, 9. Let's clean up our pencil marks. 7, 9, 8, 7, 9. So this has to be 9 now by Sudoku, which means this is a 6 by mathematics. We get a 4 over here. So now we know this is a 14 line. So how could that be 4? That's got to be 5, 9. And now this has to be 10, so that can't be 1. Ah, what'd I do? I'm on the wrong thing. Okay. That can't be 1. So there's a 1 over here. Let's go ahead and give it a proper pencil mark there. Now, do we know what this is? I don't know. Probably do if we give it a little bit more thought here on how the math could work. So 9 and 6 is 15. That can't be 6. Right. If that's 6, we're at 15, and there's no way for this to be 15. So that is a 5. And now this is 9, so that has to match it. 9, so we get the same thing there. So that means we're looking at 14 lines. So this has to be 10. So that, again, is not a 1. Why do I keep doing that? Pressing the wrong buttons. Okay. Probably some more coloring I can do. So this isn't the 1. We need a 3 and a 6 in this box. And we can do that if we just look at our pencil marks. 2, 3. Cool. Alrighty. Now, do we know this line? If that's 13, that feels awfully tight. Yeah, so this is going to be a 10. So it's a 2, 8, or a 3, 7. Okay. The point is this is a 6 and this is a 6. So this has to be the same as these two. So then this has to be the 8. That has to be 7. That has to be 1. Very nice. 3, 2, 8. Now we've got 12. So this was to 10. Yep, very cool. 1, 8 up here. This isn't 1. This isn't 2. Okay, we need 1, 2, and 7. We get 2 here, 7, and 1. And for my final trick, we have a 5 and a 7 there. So that's 8. This is 5, 7. This is a 9, it appears. All right, so we have 14, and we've got 10 so far, so that's a 4. What are these two? 1, 2, 3, 4, 5. We need 6 and 7. Not sure we know. What are these for? We need a 1, 4, 7, and 8. Okay, so let's clean up here. 4, 7, 7, 8, 7, 1, and 1. Wow, that is unfortunate. Okay, none of that's resolved, I don't think. Probably have to do the last little bit of line here. So that's 13, a minimum of 15, and that's 12 and a maximum of 15. That's beautiful. Oops, 3. I was thinking 15. That's a really nice. Oh, I can't place a 7. That's a 1, 4, 8. Nice. Thank you. Which tells us these digits. But yeah, I really like that. Actually, it got min-maxed there. That was cool. So we need a 2 and a 6. Not done, unfortunately. I suppose I could have just looked at. Yeah, okay. What are these? 1, 2, 3, so 4, 5. Wait a minute. There's only one place for 4. That's a good place to start. Let's start with that. Okay. So 1, 2, 3, 4. So 5. What's this digit? I do it the hard way. That's a 9. And then we need 5, 8, which I'm not sure we can do. Right. But we do know this line total now is 15, which I think has to be 9, 6. Oh, we did get. Oh, no, we didn't get that. There was like some. Oh, no, it was 9. Yeah, I don't remember. Anyway, 9, 6, which we can do. 9. This gives us a 2 and a 6. And I think we're just down to Sudoku, aren't we? I think so. Oh, no, there's this line over here. So this can't be 6, 2. Let's see. 1, 7, 3, 5. So this isn't 5 or 7, which means this isn't 1 or 3. But that gives me a 5, 7 pair here, giving me an 8 and 5, which means that these two digits we should know, which we all probably already did. We have a 1 we need over here, and a 9. That gives us a 3 and a 5, and a 7 and a 5. And now we should know this digit, 8. And this digit is a 1. And then what are these 3? 2, 4, 7. So that's a 7. And a 2, 4 pair. That gives us a 6 over here. Okay, 2. We need a 3, which can only go there, and a 5. In this row, we need 2, 4, and whatever this digit's going to end up being. 7. Okay. These 3. 1, 3, 8. So that's got to be the 8. 1, 3, 8, 4, 1, 2, 4, 2, and what do we have left? We need a 4 and 6. Beautiful. Yeah, I love that. I love that puzzle. That was fantastic, Riffclown. Yes. Oh, I like that a lot. Okay. Thank you so much for watching the video. I hope you enjoyed the puzzle. Until next time, bye.